If you have ever seen a pneumatic or hydraulic system in industry, you may have encountered these types of equipment with these kinds of symbols on them. These are a kind of control valve. Yes, you heard me right. There are a variety of well-known control valves in the industry, such as glove valves, that you can watch our video about it from the link in the description. But today's video is about different types of control valves, known as directional control valves, or DCVs for short. You may hear of them as solenoid valves or spool valves as well. If you want to know how they work and how you should read and interpret their symbols, stay tuned for the rest of this video, and please subscribe and click the notification bell for more videos like this. The control valves are mostly known by their adjustability and throttling capabilities. But the valves we are going to talk about them are the types that control the direction of the liquid flowing inside the pipe. Directional control valves are used in pneumatic and hydraulic flow control systems. So, there are pneumatic directional control valves and hydraulic directional control valves. Sometimes, the hydraulic directional control valves are called spool valves. As we're talking about the basics of DCVs in this video, and there's not much difference in their working principle and symbols, we develop our example based on a pneumatic system. And of course, if you learn one of them, you can easily learn the other. Let's start with this simple pneumatic circuitry and then see which parts does a directional control valve has. The main power of this pneumatic system is coming from the compressed air that is supplied by a compressor. The directional control valve is directing the flow of the compressed air in two different directions to open and close this slide gate valve using this actuator, which is a double-acting cylinder. A double-acting cylinder has an air chamber on each side of it to move the piston back and forth. One of the directions extends the cylinder and closes the slide gate valve to block the material coming out of the silo. And the other direction retracts the cylinder to its first position. Therefore, the slide gate valve is a normally closed valve. Meanwhile, the sound you hear is the air inside the cylinder exhausting from the valve into the atmosphere. Now, let's take a look at the components and simplified mechanism of this directional control valve. This is the body or housing of the control valve, inside of which there are the paths that air flows through them. The holes you see here are called ports. Within the housing, there is a moving part that leads the air toward different ports of the valve and blocks the others. This moving part is commonly referred to as a spool. The component that causes the spool to move within the housing is an electric solenoid. This is the neutral or rest position of the spool. As you may be familiar with solenoids, when it gets energized by a command from the PLC card, the coil will push the spool and thus it will squeeze the spring on the other side. As a result, you see the piston of the cylinder move to the right side. As long as the PLC's commands remains on the solenoid, the position of the spool will remain still, and the compressed air will cause the piston to keep its last position. As soon as the PLC removes the command, the spring will return the spool to its first position, and the air path will be changed. Therefore, the air behind the piston will be purged into the atmosphere via the valve exhaust port. Now it's time to learn how these valves are called and how to read their graphic symbols. This valve is known as a 5x2 solenoid valve, or a 5x2 pneumatic directional control valve. The first digit is for the number of ports the valve has, and the second digit is for the number of states the spool can be in. Reading and interpreting the symbols may seem a little bit challenging sometimes. For instance, this directional control valve has such a symbol. Each square in the symbol represents a position or state. And in each state, some arrows show the path that air can flow through them and that specific position. As I've mentioned, this valve has 5 ports, and this is the ISO designation of the ports, which is a common practice. But sometimes, you may see an alternative designation of the ports in DCVs by alphabets, in which the P is for power or pressure that comes from the air source. The EA and EB are for the exhaust ports, and the A and B are the output ports to or from the actuator. This is the sign for the electric solenoid, and this one is for the spring return. In our circuit, when the valve is in a stress position, this square is active. When the solenoid gets energized and the spool changes position, the other one is active. Generally, the square just beside the solenoid sign is active when the solenoid is energized, and this is a rule of thumb for any directional control valve schematic. In the end, keep in mind that there are a variety of other directional control valves with more complex functions in different applications that we can check them in future videos if you like this one. If this video helped you, please subscribe and hit the like button.